All right, everybody, welcome to our Help and Tips Part 3. Hopefully, Parts 1 and 2 were very helpful for you and that you're comfortable with all of that. That will all lead into this, a lot of the basics you've seen. But this one will be pretty helpful going forward. You'll probably refer back to this one a lot because we'll do the basics of plotting of histograms, box plots, and scatter plots, and then just how to find a correlation coefficient. So this one you'll probably use a fair amount. As usual with these script files, I've added more than what you will need for this course, but I wanted to make sure I gave you sort of the minimum amount of tools to work with some of these things, do some of these plots. Any specific thing I want from you with the plot, I will always ask for. So I don't want you to guess what you'll need to do when you're plotting or coming up with your graphs for things. But graphing is a tremendous part of choosing our model and also then assessing our model later on. So we'll be using these types of graphs a lot. And there are other graphs too that will come out in other R help and tips videos. So to start off, let's load up some data, and let's use this NBA data again that I had us use before. And so I'm just going to import it with Control-Enter, the way I like to import data. And I'm just going to take a look at it here. Everything looks good, and I can run the str function and check it. Everything looks good. So let's say I want to find a histogram, and let's remind ourselves that a histogram is just to say, hey, I've got a variable. What does the variation in that variable look like? How is that variable distributed? So for our data, let's remind ourselves that each row is a team. And let's say I wanted to ask about the average points per game in this season for all of these NBA teams. So I've got a points per game variable, and just looking at it, I've got some points per game averages in the low 100s, some in the high 90s, a little bit of variation there. I got one down to 91.9. So what if I want to graph this and say, what does this variation look like? Well, the basic command is hist, H-I-S-T. And the convention is hopefully what you're getting used to, and that's the name of the data frame, $, and then the name of the variable that I want to plot. In this case, pts.g. So I will do Control-Enter, and there it is. Now here's some important things to notice. Well, one, I didn't specify any options. We will specify options in a second, but this is just what R chose to do in terms of setting different options. Three things to point out. One, it gave me a default title. It said histogram of, and then the name of the variable and the name of the data frame that I inputted in the command up here. That's what the default title will be. It also gave me a default X label of exactly this thing here that was in the title, NBA $15 pts.g. You can change this. I will say this, unless I specifically ask you to change it, the title or the X label, I will not care if you change this or not. It's up to you if you want to have a better title. It's up to you if you want to label this. As you go along in your studies and your projects, I'm sure you have made graphs or will make graphs in the future where it is absolutely essential that you label these things certain ways. I'm not worried about that because that's not, for me, what this class is about. I just want you to be able to interpret what's going on in here. The other important thing is that it chose the number of bins here, or the number of bars. R also uses the term breaks. But all I did was just run this variable, and it chose 4 bars for me. So sometimes that'll be okay. But maybe, let's say I want more bars. Maybe I want more breaks. So let's say I tell it, I add this option. And remember, whenever we want to add options to things, we just do comma. So we have the original command of NBA $15 points per game. And then when I want to add options, I just add comma. and then breaks equals, and then the number of breaks that I want. Great. So now I have more breaks. And this is okay. I mean, it's a lot of bars now, and if you look at the axis here, these last 3 bars are just counting one team each. It's just 1, 1, 1, all the way over there. So it's not, this doesn't necessarily, it's not as nice looking. It's got a lot of categories. So that's not necessarily showing the variation that I want to see. So what I can do something even farther. I can specify exactly where on the x-axis I want these bars to appear. And so I've already done that here. And again, I've done comma, and I've added very specific breakpoints for my histogram. And there we are. And I like this. Yeah, I've got this last category here, this last team just has a frequency of 1, but it's on the edge, so I'm not worried about it. This, I think, shows me a good distribution of what's going on. 8 teams in this bracket, 6 teams in this bracket, 6 teams in this bracket. So it looks nice. If I want to change the title, I can just do comma, and then the command is main equals, and then add in the name of my title. And notice I put in the title option. I didn't put in any of these other options with breaks. So obviously it's just going to give me the default number of breaks like it did the first time. If I want to separately change the X label, the X-axis label, it's just XLab. And there we go. But again, I've got the default title, the default number of breaks, but now I've got average points per game as my X label. So let's say I want to put all these options together. I want to specify the number of breaks, I want to change the title, and I want to change the X label. I just put commas after everything, and I'm going to highlight everything and hit Control Enter. And ta-da, there it is. Beautiful histogram. Got a custom title, a custom X-axis label, and a custom number of breaks. Again, I'm not going to require that you do custom titles or labels or even custom breaks. If you can do what I'm going to ask you to do with, say, this kind of histogram, then that's great. Then that's fine. I'll leave that up to you. So that's the histogram. Another option that you might consider as we graph our data, to look at our data, and again, we're going to be doing this a lot to assess and help us choose our models and to figure out if they're useful or not. You can use a box plot, and the convention is the same. The command is just box plot, and I specify the variable in question that I want to look at, points per game again, and here we go. Again, not very helpful. Let me just skip to these other options here. If I want to add a title, I can do main again and add the title of this plot. If I want to do a label, now before I labeled the x-axis, which was down here. Well, there's no axis here. The axis, the way R has graphed it, is now over here. It's on the y-axis. So instead of doing XLAB, I do YLAB. And that gives me a nice Y label over here, average points per game. And again, if I want to put it all together, I just put commas after everything and hit Control Enter. And there we go. There's a box plot. So just a quick little reminder from your descriptive statistics class about what a box plot is and what it's showing. Remember that this middle line is the median. The first line here is the first quartile. The third line here is the third quartile. And so the first, second, and third quartiles make up our box. And there are important things to note about the dotted line and these boundaries out here. Remember that an outlier in statistics, we tend to define it as 1.5 times the interquartile range and any point beyond 1.5 times the interquartile range above the third quartile, and 1.5 times the interquartile range below the first quartile. If there are no outliers in your variable, then these fences show you the minimum value and the maximum value. So this is the minimum value and the maximum value. If you have outliers, which there are no outliers in this box plot, they will be a circle beyond the fence, and the fence for whatever side has the outlier is now that, in a sense, that boundary of 1.5 minus, 1.5 below, 1.5 times the interquartile range below the first quartile, and 1.5 plus 1.5 times the interquartile range plus the third quartile. So this will either be a minimum and a maximum, or it'll be the outlier boundary, and then you'll see outliers beyond it. That's all that is. So let's say we want to look at two variables. These were all one variable statistics, the histogram and the box plot. Well, I can look at a scatter plot. I can also look at a conditional box plot split over two groups. I don't think I'm going to have you do this too much. But let's say I wanted to look at the distribution of points per game, depending on whether or not a team made it in the playoffs. Well, I can do that by, again, specifying box plot, and then specifying the variable I want to see the distribution of. Then I can do a little squiggle line, the tilde, and specify the variable that is categorical, that has categories, that will then split up my box plot. So this isn't particularly useful unless you know exactly what the data look like, because you have to know what 0 is, you have to know what 1 is. So but we'll get to that in a second. But again, I can add a title here with main. I can add a Y label with Y label. Here's the important thing. If I want to name what's going on with these two boxes here and what they're each showing, the option I add is names equals C, and then I specify what these two things are. Now, because I made this data, I know that the first one, the 0, is non-playoff teams, teams that didn't make the NBA playoffs that season. And I know that the second one is representing playoff teams. So let me put it all together just to show you the final thing. So again, I'm going to show the distribution of points per game, and I'm going to split that up between teams that didn't make the playoffs and teams that did make the playoffs. I'm going to add my title. I'm going to add my Y label for my Y-axis, and I'm going to label each of the categories of my playoff variable. And there it is. So I've got a box plot of points per game conditioned on whether or not a team made it to the playoffs. So again, no outliers. So these outer boundaries here, that's the minimum average points per game for non-playoff teams. That's the minimum average points per game for playoff teams, and then the maximums for each of those. But just looking at this, you can see some interesting things happening, which is why box plot can be very useful. You probably won't use one very much, but it's good to know how to make them, and as you can see, they can show you some interesting things right away. And again, if you just do this basic one, and that's good enough for me in terms of what you need to show if you provide a box plot. So let's pick this up in the next video to get to our most important